So good afternoon, everyone. Welcome to the November Food for Sustainability webinar, this time dedicated to recirculating aquaculture systems. It's a true pleasure to have you here with us. My name is Claudia Costa. I will be today's moderator, and I am the coordinator of Food for Sustainability Academy, which is the hub in Food for Sustainability dedicated to education and dissemination about sustainable agri-food systems. As you know, these webinars are brought to you by Food for Sustainability, which is a private, not-for-profit collaborative laboratory working to promote sustainable intensification of the agri-food system. So we work on specific areas such as circular economy, where RAS systems, of course, have a very good fit, sustainable agriculture, specifically trying to understand and manage soil microbiome. We also work on natural capital, where we have projects on carbon sequestration, biodiversity, and water management. And finally, we have a working area on sustainable eating, where we link soil microbiome with human gut microbiome. So if you want to know more about Food for Sustainability, I think Rita will put you a hint on the chat where you can find more about us. And since it's lunchtime, I hope you are all in for fish, because this is the topic we'll be addressing. So specifically, what can recirculating aquaculture systems do for sustainable fish production? As you are all aware, in a scenario of increased likelihood of food shortage, we have challenges such as climate change, growing population, loss of biodiversity, pollution, nutrient deficiency, so huge complex problems. It's very timely for us to look at new models of producing food and producing food in a sustainable way. So this session, which is powered by AmpliAqua, which is a project funded by EEA grants, we will be looking at how recirculating aquaculture systems can indeed contribute to raising the standard of sustainability in food production, specifically fish farming. So we will address topics: how can the use of mechanical and biological filters to remove matters and metabolites allow for a more sustainable system, including allowing for high-density cultures, putting less strain in resources like land and water, and of course, as such, facing this increased demand for seafood proteins. And to have this discussion, I am joined by our distinguished speakers, which I deeply thank for their presence here. And they will be sharing their international experience in aquaculture. We'll also be investigating the opportunities and challenges of RAS systems, and looking ways of controlling for success of this technology. Of course, giving you examples of successful projects throughout the world. And with us, we have the pleasure of having, now I'm going to change the order, Svein Martinsen, which is the head of development at Morefish. Thank you, Svein, for being here. Truly appreciated. We also have Rui Gonçalves, which has over 15 years hands-on experience in the aquaculture sector. Many thanks, Rui, for your availability. We also have Paulo, who is an aquatic production specialist here at Food for Sustainability. Paulo, many thanks for your presence. And our last speaker will be Inger Lise. She's the head of fish health in the western region of Åkerblå. I'm sure that Inger can fill us a little bit more about where this region is. Thank you so much, Inger, also for being here. It's really a true pleasure. I'm really honored to have such a distinguished panel with us. Many thanks. So very briefly, our format will follow roughly 1.5 hours discussion. I'll try to do my best to keep everything on time, and we will have 2 presentations followed by Q&A. I will invite you to use the chat here to pose our questions to our speakers. Then we'll have two other presentations, and then we have a wrap-up by Paulo Frias, again followed by Q&A to our participants. So please use the chat. If you feel that the chat is not enough, I'm sure all the speakers will be available to answer your questions either after this webinar or through email. So please feel free to contribute. But before I turn to our first speaker, I would like to give the floor to Sandra Silva. Sandra comes from DGPM, which stands for, and I will say it in Portuguese, Direção-Geral de Política e Mar. This is a department in the Sea Ministry. So, Sandra, welcome to our webinar, and the floor is now yours.
Thank you so much. It's nice to be here. Yes, I'm Sandra Silva from Director General for Maritime Policy under the government of the Ministry of the Economy and Maritime Affairs. And we are here as the program operator of the Blue Growth Program from the grants. This is the program that is being funding this project that was selected. And just to give you just some scope of the program, this program, the main objective is to increase the value added from our SMEs especially. So it is related with business development that brings innovation in the blue economy. So in the most important is to fund companies, special small companies, in order to innovate in their products, in their services, or in their production way to do better and in a more efficient task. Our program also funds projects under research, because research is very related with business development in order to bring innovation, and also with education, because if we are innovating in many sectors under the blue economy, we need to upgrade the skills and the competences from the workers or from the students. Of course, another objective of this program also is to strengthen the bilateral relations between entities from Portugal and from the donor countries. And donor countries are Norway, Iceland, and Liechtenstein. And your project is one example how you collaborate and cooperate with the entities from Norway in these projects. So it is just, I would not to take a lot of time for workshop, because the most important is you to discuss this topic, and also to present the results and to understand what you are doing in your project that from itself brings lots of innovation in this particular field of the aquaculture and the aquaponic. So thank you so much for being here. We will listen your discussions, the speakers, and so thank you.
Thank you, Sandra, and for this very brief interview about business development and the opportunities that the sector poses. So hopefully our participants can start to link the dots, how they can develop their ideas and find synergies. Many thanks. Yeah. So now let's turn to our speakers, and the first is going to be Paulo Frias from Food for Sustainability, our aquaculture production specialist. Paulo, when you're ready, the floor is yours.
Okay, Claudia, thank you. Can you see my presentation?
Yes.
So perfect. So good morning, everyone. I'm here today to present our AmpliAqua project. So this project is funded by the grants, and it also has the funding from the AET Food, and is coordinated by BGI and with the national partners Food for Sustainability, where I work, and Aqualguy, and our Norwegian partners IDN and Morefish. So AmpliAqua will be much more than just an R&D project. We are building a pilot facility for innovation in aquaponics. It will be a place to carry out tests and look into solutions to the challenge of aquaponics. I will do just a brief explanation about what is aquaponics for the ones who may not know. So aquaponics is the combined culture of fish and plants without soil in a recirculating system. So in these systems, the water flows from the fish tank to the hydroponics, but first runs through filters, mechanical and biological filters. And in the mechanical filters, the solid waste from feces and uneaten food is removed. And in the biofilter, the ammonia is converted first to nitrates and then nitrates in a process called nitrification. So this water containing nitrates and other nutrients travels to the hydroponics, where the vegetables uptake the nutrients, and finally the water returns to the fish tanks. So aquaponics has great advantages as it uses the agricultural waste as nutrients for plants that are normally wasted if you run just an aquaculture facility, and is resource efficient as water recirculates from one system to another. It also needs between 70 and 90% less water than traditional agriculture to grow the same amount of vegetables. Unfortunately, there are no perfect systems, and the main disadvantage of these systems are the initial startup costs, the complexity of the systems, since you have two completely different productions that have to complement each other, and the energy consumption is higher compared to soil farming. This is a diagram of a traditional aquaponics system. They are called single loop or one loop system, which mean, as I told you on the previous slide, that the water flows from the fish tank to the hydroponic component, returning to the fish tank. This has a huge disadvantage, that is the difficult to provide the optimal parameters for both fish and vegetables. This means that the productivity is affected and is less efficient for one of the products. To give just one quick example, the optimum pH for vegetables is between 6 and 6.5, while for fish, the optimum pH is above 7. As I also mentioned on the previous slide, in this one loop system, the solid waste is removed by the mechanical filter, which leads to a waste of nutrients. So one of the AmpliAqua's goal is to improve the use of solid waste from aquaculture. At AmpliAqua, we are going to use a different approach based on a PhD thesis made at Wageningen University. In this approach, and in order to improve the efficiency of the aquaponic systems, we use a decoupled system or a multi-loop system. This means that the aquaculture and hydroponic systems are separated, are independent, so we can have optimum parameters for fish and plants. But also, in this system, we can make much more efficient use of the nutrients coming from the aquaculture. So instead of being discharged, the sludge is retaining and undergoes to a process that can be aerobic or anaerobic. In this diagram, it shows the anaerobic treatment. So very briefly, the sludge is removed from fish tanks, placed in a bioreactor, where it's broken down by bacteria, resulting in a liquid that is rich in dissolved nutrients. And only this liquid is added to the hydroponic system. This also allows us to have a better control on the nutrient concentration on the hydroponics component. Another of the AmpliAqua's objectives is, and this is one is related to aquaculture RAS systems, is the elimination of flavor. of flavor is a earthy smell, taste caused by mainly two organic compounds that are produced by bacteria that may be present in the aquaculture system. Those compounds are geosmin and 2-MIB. So the standard process to remove these compounds requires the fish to be purged using high amounts of fresh and or highly treated water for several days. So which results in economic loss over this period of time, not only due to the expense of new or treated water, but also due to the fish losing weight because they do not eat during purging time. What we want to do is test some methodologies combining ozone and UV or ozone and hydrogen peroxide to reduce the purging time and eliminate from the system the bacteria that produce those compounds. Another major objective of this project is digitalization. So RAS systems are often complex, and better monitoring can prevent losses or anticipate problems. Monitoring should be more complete than just temperature and dissolved oxygen control, and the goal is to add more relevant sensors and have a better control over the facility. On another end, we intend to test image processing equipment and software, for example, underwater cameras for biomass estimation, detecting wounds or disease in fish, spot uneaten feed at the bottom of the tanks, etc. Anything that might be difficult for the aquaculture operator to detect in time. The same concept can be applied to the hydroponics to find out if there are any nutritional deficiencies or disease in plants. This year, we also won the Portuguese Recovery and Resilience Plan, the acronym PRR in Portuguese, so that our facilities can be used as test beds. This means that any Portuguese company that wants to test a product or equipment in aquaculture or hydroponic can use our facilities for this purpose at reduced price, since part of them are co-funded by the PRR. As we felt that the challenge of producing fish and vegetables wasn't enough, we decided to add another layer of complexity and another trophic level to the system. So in the end, we'll have 3 commercial products. We'll have fish, vegetables, and microalgae. Basically, we're going to use the nutrient-rich liquid extracted from the fish sludge as nutrients to test the microalgae's growth. We will try several different microalgae species, and we will use the most suitable ones. But of course, they need to have commercial value, or either from their protein or fatty acid content, or because any other biostimulant and antioxidant compound present in these algae. So this AmpliAqua facility is intended to be more than just a test site for innovation. We also want to be a place to develop other R&D projects, to be a place for test beds, and we also want to provide training. Regarding training, as Claudia also said, I will present a brief information at the end of the webinar about 2 training courses that we have planned for next year. So this is the preliminary layout of the AmpliAqua's facilities. As you can see, there is an area dedicated to fish production, another for R&D tests, and a set of greenhouses for hydroponics and microalgae. These aquaculture rooms are all independent and have their own RAS system, and we are able in these facilities to run both fresh and salt water in every room. You cannot see in this picture, but the building has 2 floors, and on the second floor we'll have a laboratory, training rooms, open space for incubating startups, and also some dormitories for the researchers who come to use our facilities. And that's it for my end.
Thank you so much, Paulo. That's very interesting. I hope you have open days for those that are not experts in aquaponics, but to visit such an interesting project. Paulo, just one quick question. You mentioned that AmpliAqua can be used as a demonstration or a testing site. Who would be the contact point for those to be interested in knowing a little bit more about that?
So you can contact me or probably João Rabassa or Gonçalo Amorim at BGI. They will know everything about it. So it's quite easy to have some news.
Fantastic, Paulo. Thank you so much. Probably you can just type those contact points in the chat for our participants to ensure that we have more collaborative projects and developments in the near future. And we already have our second presentation on, so very efficient. We have Svein Martinsen. As I mentioned, he's the head of the development at Morefish. Svein, when you're ready, the floor is yours.
Thank you, Claudia. All right, I'll just start. Just a bit about Morefish. We are a Norwegian company, advisory and industrial R&D company. We have a lot of technical and biological expertise that we put into the projects, and we also try to implement the new R&D knowledge and best practice. We have a deep focus on fish welfare and biocircularity, and most of all, trying to develop safe fish farms. At last, we also do a lot of training. We have our own Morefish Academy where we supply training for the operators of RAS farms in Norway, but also also abroad. We are well, 2 years ago, we started collaborating with the BGI and Food for Sustainability, and we're part of this project that Paulo presented. Okay, I'm going to talk about the main drivers in RAS technology. Just a quick overview of the Norwegian aquaculture. Maybe most of you know that we're a big salmon producer, and unfortunately, it's almost the only species we farm. We have some other species as well, but not by near the volume that salmon farm is for time. And this is a typical salmon farm, sea cage farming in a fjord or in the ocean. And this can produce like 8,000 tons of salmon per year in these cages. To support this type of scale industry, we need to produce the smaller fish, the smolt, on land, and to support the growth. Even in Norway, we don't have enough fresh water to produce the smolts, so we need to convert to recirculation technology. And this is a typical RAS farm in northern Norway, maybe 2,000 to 4,000 ton production on land. It's quite new, and we have the whole production run here. So the RAS technology is entered the market in Norway for like 15 years ago, but still we think that the technology is not complete mature to have 100% safe production. I'm going to talk a bit about these main drivers that is challenging. I will just show you the volume, the increase in volume in salmon farming. 1.6 million tons is produced last year, and out of that we need like 450 million smolts produced on land, and maybe 50-60% of these smolts are produced in RAS, the rest in flow-through systems. But it's not risk-free, it's not 100% safe. These numbers are presented at our conference. We have a risk conference in Morefish a couple of weeks ago, and this is the mortality reported from several RAS, not only RAS farms, but land-based farms. And as you can see, there are numbers up to 2 million dead fish in one case, and lots of other high numbers as well. And this is not good at all. And there are some drivers that causes these problems, and there are also some possibilities to reduce it. So let's look into that. Basically, in a RAS farm, you put water in to have biosecurity. You maybe treat the water in, you clean it, and the same for the water that goes out to the recipient. You need to treat it and clean it. But inside the farm, you have a lot of variables. You have technology, many components working together. You have the biology, which is not constant. It's you have, for example, bacterial growth, which is changing. You have water chemistry, definitely not constant. You need to move the fish. It's a big pressure on the fish. You stress it. You move it from tank to tank, or vaccination and so on. You have some sensoric systems, which I think is not good enough. You have the fish welfare, which is defining your production in terms of economy, and also how the community see your production. You have data processing, lots of data that can be used, and you have risk mitigation, how to avoid risk that causes failures. And there's many more, but it's a lot of things to develop and be better. And the graph to the left shows that the less water you want to use in a farm, the more complex your farm will be. Typical failures when you reduce the water consumption is that if you overfeed, then you can pollute the water in the tanks. You can have poor particle removal, poor gas removal. You can have changes in pH in the water chemistry that causes changes in other parameters that might be lethal to the fish. The logistics I spoke about could cause too much damage, so the fish could develop diseases. And disease, of course, it's a challenge because it's highly intensive production, and if you have disease in one department, then the risk of spreading to the next department is there. And of course, the instability of the system, it's usually a challenge. We want to have stable systems, but it's not so easy in practice. So the solution to pollution is dilution, and in this case, maybe you have less failures or challenges in a flow-through system, but you cannot guarantee there either. But I think we can manage to reduce these challenges. For sensoric systems, just to show you, this is an oil installation in the North Sea, and we have developed technology to control this. Maybe from the office back home, but not a fish farm. We have not complete systems to run a fish farm. To have control, we need to have better control of all the water quality parameters. We need to have control of the feeding and the biomass. And these pictures are some examples of technology that's developed in the recent years. Like camera, you have automatic biomass detection, and new robust sensoric systems. If you have control on this, you can have a more stable water quality. You can reduce the loss in feeding, and maybe avoid unfavorable water quality. Next one up, difficult part of the RAS system, the biofilter. biofilter management. These biofilters are not 100% stable, and these functional biofilters can cause lethal levels of, for example, ammonia. And this graph is showing the changes in the levels of this ammonia. And these biofilters are also a problem because in some farms this might cause accumulation of sludge in the tank and maybe provoke H2S, hydrogen sulfide outbreaks. Particle removal management is not particle removal in these farms are not good enough. Maybe 50-60% of the particles are removed. And remember, the fish, when you feed the fish 1 kilo feed, 25% of this is undigested, so it ends up as particles in the system. High particle loading in fish tanks can provoke gill inflammation on the fish, and in worst case, the formation of hydrogen sulfide and mass mortality, and also risk for higher oxygen consumption. So there are things to do with the particle removal. The gas management also, you can have high CO2 as the fish is releasing that to the water. And nitrogen gas supersaturation is also very lethal to the fish, the same as H2S. So gas management is well, it's not difficult. It's difficult to measure gas in water, but we have sensoric for that, but it should be a better technology for this, and also more efficient systems for degassing the water. And for nitrogen gas and H2S, mass mortality happens within very limited time, a few minutes from where start to the that you have very high level of mortality. This is nitrogen gas supersaturation. This is from the gill of the fish. It gets bubbles in the gills and under the skin, which can create mortality. And the last, disease management in these intensive farms. Every farm producing live animals should have this plan for biosecurity, and in this type of farms, it's very important that the focus on how to manage the biosecurity is raised to a high level. Lise is going to talk later. She's working in fish health industry. She will talk a bit more about this. But all the farms in Norway is connected to a fish health service, and we do a lot of mapping on different diseases that might occur in the farm, and have a great focus on fish welfare and biosecurity. This is an example, the picture at the left from a virus found on gills of salmon, which is a typical virus that is found in RAS farms. So to manage all this, to manage an increased production in RAS farms, there are different drivers. These are only a few of them. It's a lot more to focus on, but if you have control on this, then you have a good platform for doing a good production. Usually we talk in 6 days in our RAS course, training course about this, but this is the very, very short version. But if you have questions, send me an email, and we can see if we have some answers, or put you in contact with people who can answer the questions.
Okay, it's fine. Thank you so much. It was really a very interesting presentation, very clearly presenting the challenges of RAS systems. I'm glad that I'm not working on those because they seem quite complex and quite a few. So I will invite our participants to use the chat to ask some questions to Paulo and Svein. But while our participants don't come to the front, could you both of you explain how does the AmpliAqua system complements the work that Morefish is doing? Where the synergies are, where you think are the main points of contributions, and also if you could let us know what would be the win-win situations for consumers.
So I think I can start, Sven.
Yep.
So Morefish and Sven, they are really experts in assembling RAS systems, and for the RAS systems to work, they have to be really well. Each part needs to be really well sized. So if all these calculations are okay, the RAS system has a much more probability of work well. And that's our interactions between Morefish. It's one of the interactions. Of course, we are also trying to solve the off flavor issue, as I explained in the presentation. And I think the convenient part of use a RAS system is that we recirculate the water, and we use almost more than 90% of the same water. So in terms of sustainability, there is the big advantage of the RAS system.
Okay, thank you, Paulo. Fine. From your perspective?
Yeah, I think we should not believe that the RAS technology is fully developed, because it has potential to become much more safer. And these loss numbers that I showed is it's not a nice thing to to present to the customers. And you need to know the customers are more and more concerned about the animal welfare in the production, and I think we need to improve the technology and the operation process. And doing this with other environments than the salmon thinking Norwegians, I think it's very wise, because they maybe tend to think in a certain way. And that makes it very interesting for us to collaborate with BGI and other environment. And for the customers, consumers, knowing that the fish has been produced in safe systems without compromising fish welfare is a selling point. I think that will be enforced in the future.
Okay, that's interesting, because I think you cracked a very difficult problem when you touch the consumers, which is to communicate sustainability. And the way we convey this message, and clearly your positioning is through animal welfare, which is very interesting, because all the other issues around aquaculture and aquaponic can be quite hard to communicate to the everyday consumers. I don't think we heard from AmpliAqua. What sort of fish do you farm?
So that's a good question, Claudia. As it is an aquaponics system, it has to be a freshwater fish. So our expectation in the beginning was to use salmon, because it has a freshwater phase in the beginning, and then it moves to saltwater. But we are still open for every kind of fish, but salmon looks appealing to us.
Okay, so it's an opportunity also for our participants to come forward and to start closer conversations with AmpliAqua for new solutions and new testing. I have another question. While you were describing the RAS system, you mentioned solid wastes and the nitrates that you collect. My question is, this is an opportunity also for the agriculture industry, for farmers. What is the receptivity of farmers to use products from a system, from a technology that it's probably perceived as more complex? They don't really understand what is this byproduct. What sort of feedback do you have from using this byproduct in a different industry?
Well, in Norway, some of the fish farms, they supply agriculture farmers with the sludge, and they just use it as a fertilizer on the field. And it has some restrictions due to some increased levels of heavy metals, actually, in some areas. Other utilization is to use it as a substrate for biogas, which is several farms in Norway are doing that now. And you can also use it for composting in connection on or together with the wood chips, for example, or other materials. And there's a lot of, well, it's not a lot. There are some phosphorus in the sludge that should be recaptured and reused. And it's for a RAS farm, you have a concentrated stream out of the farm, so it's more doable to recapture this the phosphorus from this stream compared to other fish farm technology.
Okay, that's interesting. There's already some awareness of some synergies with the RAS systems. We have a question. Rachel has placed the question. This is very small here in my screen. Apologies. So, hello, Paulo. You just need some halophytes or seaweeds in your aquaponics system. Okay.
Yes, that's true. If you use halophytes or seaweeds, we can do the aquaculture with marine fishes. So that's quite true. We do see some value in the microalgae, so we are trying to first go to these freshwater microalgae, and we do see also some higher value with the vegetables. So for now, halophytes and seaweeds are in the standby position.
Okay, but they are part of the equation at the moment.
Course.
So
yes, of course.
Just because we still have a couple of minutes, just to give a perspective of RAS systems in terms of consumption. How much of the production is actually coming from RAS systems? Can you give me round figures so that we can understand?
In Norway or globally?
Well, the ones that you have. I would like to hear both, to be honest.
Yeah, well, land-based production in Norway, basically smolt production is around 100,000 tons, and maybe 60% is produced in RAS. We have a few land-based grow-out farms, but not very high volume per today. And there are some farms abroad, like Atlantic Sapphire, that you might have heard of. You have Kingfish Zeeland with the yellowtail in Holland, and but in the total picture, it's very low percentage. But the potential is very high because you can do RAS production everywhere. You have a RAS salmon farm in Dubai, actually, and there are salmon farms in in the couple of hours west of Washington in the US. So it's doable everywhere, actually, if you have water.
That's the beauty of these systems, is that you can move food production to almost anywhere as long as you have water. We have Cherry also here with a question. Is RAS applicable in indoor crayfish farming? It's a specific one.
Yes. Yeah. It is. There's a small farm in Norway, but crayfish is not a big farming species in Norway. But elsewhere, I think there are some smaller farms. If you Google it, I think you might find some contacts.
Okay, it's possible, but it's still not mainstream. I believe also the systems will be driven by consumer demand. So I can imagine that salmon plays, a huge chunk of consumption demand also. So thank you so much. That was really interesting. Thank you so much. I will ask you to stay here with us. Even I will now move on to the next speaker, but I will come to your question later on. So now in line, we have Rui Gonçalves. Rui, thank you for being here. Rui is going to tell us a little bit more about what are RAS systems. So a tool, a system, and let's find out what else. Rui, the floor is now yours.
Okay. Can you hear me? Yes?
Yes, we can hear you fine. Yeah. Thank you.
Okay, thank you. So, well, thank you. Thank you very much for the introduction and for the opportunity to make this presentation. So my goal here will be kind of to give a different perspective from our colleagues from Norway, and also a little bit a different perspective from the idea that we have of RAS systems in Europe. And I think Svein mentioned very well the complexity of the RAS. And my goal during the presentation will be more focusing on the method itself. So, and not like on the complexity of the equipment that have been kind of growing with the time. And what we find nowadays is that you really need to have like the fish experts and also the RAS experts at the same farm, which of course has consequences for the production costs. And this is the kind of the perspective that I want to bring to the table for the discussion, and especially here in Asia. So I'm based in Singapore, and I have been working in Southeast Asia for the last 10 years. And this is kind of what I want to share with the audience and with the other speakers as well. Okay, so when we look to the world aquaculture production, and I love this world map from FAO, which the continents are kind of manipulated to represent the production. So, and of course, China, it's the biggest production, the biggest producer of aquaculture. Truly, that is, many of the species are freshwater species, and for internal consume and with low profitability, but still Asia, it's one of the biggest producers if we exclude China, and most of the examples that I will bring, it will be mostly from Southeast Asia, and the truth is that when we look to Asia and for the RAS system, I think that most of the literature and the experts, they agree that RAS is not widely applied in Southeast Asia, and what I want to explore a little bit is why it's not applied in Asia. And actually, if this is true, if it's not really applied, and that's why at the beginning I said that I will be mostly focusing on the method itself, and not in this concept that we have that was kind of adopted by the Norwegians and the European vision of the RAS system. Well, as Svein was mentioning, so I could recuperate this time frame from a recent review paper from Ahmed 2021 about the RAS system. And there is nothing new about RAS. So it started to be researched in the 50s in Japan. and somehow was kind of abandoned in Asia, at least its commercial application, and it was mostly developed in Europe and just by curiosity. So around the 80s, it was implemented in Portugal for our Portuguese audience. So actually in 1982, it was built the first hatchery in Portugal for European sea bream and sea bass applying the RAS technology. And since there, especially during the last years, there was a really a bloom in the RAS technology, and we can see a lot of new companies providing the equipment, but also providing the knowledge for these systems. So sorry, okay. So, but one of the things that I wanted to bring to the discussion is why the RAS is lagging its implementation in Asia, and as Svein was mentioning very well, so it's a very costly engineering approach to install and to operate, and I think this might be one of the reasons, of course. So I could recuperate some values from the literature, which it's not recent literature, but when we compare the production costs in RAS systems, which these values might not be updated already, but there is still a huge difference from a RAS system to a conventional pond, and this, of course, not considering the advantages and disadvantages of each system, but there is still a very big difference. And one of the things that is also very important here in Southeast Asia is the payback period. So just to give you kind of an idea, so one of the main species cultivated in Southeast Asia is the shrimp. So the life cycle to the market, it's in the maximum 4 months. So in 4 months, you can have from a PL, from a pause larvae to commercial size. And most of the times it's around three months. And even when you go for the tropical marine species that sometimes are cultivated in the RAS system, we are talking about 8 months in the maximum. So when we compare like payback periods of 8 years, for the farmers in Southeast Asia, 8 years is quite a long time. So, and this might be also a kind of a bottleneck on the implementation of RAS systems in Southeast Asia. And of course, for the Atlantic salmon, we have quite a lot of information. I'm happy to know that a lot of challenges are still to be solved. So it means that we will not lack job in the near future. But when we look to the tropical freshwater and marine water species, so there is almost no information about these species, and this probably is also kind of a big challenge on how to implement these systems when you sometimes even don't know the biological aspects of these species. Well, and of course, what I was mentioning before, the cost structure of Asian aquaculture is very much different from the Atlantic salmon. So the Atlantic salmon, it's a quite high value species. It's a market price, and when we look to the aquaculture in Asia, even the tropical marine species, they are not so high in the market value. So you have some exceptions like the groupers, but with the exception of the groupers, most of the species will be sold with less than $7 per kilogram. So, but this is not an excuse, and in Southeast Asia we have a lot of challenges, especially on diseases, and I will give you some examples on this later. And the environmental parameters like salinity and temperature are two main factors that it's very difficult to control in all Southeast Asia, especially during the rainy seasons. And of course, water supply is also a big issue. So RAS is being looked as a solution, but energy is still a constraint. So I saw that there was a short question about the energy. So this is kind of the values that I found in literature about the RAS energy consumption, and there is quite a huge difference still. So I guess all these values are very dependent on the type of systems and the type of equipment that you have in your RAS system. But at the end, there is still a huge difference from a flow-through system to a RAS system. And in the case of Asia, we need to consider that there is some countries, and for example, if you think like in Mekong Delta in Vietnam, that farms are located in places that you don't even have electrical grids. So it's very difficult to get energy, and when you get, it's very costly. So, but the perspective is that the increase of sustainable energy sources, especially solar and wind, that is growing quite a lot in Southeast Asia, it might change this picture, and it might also be a factor for the uptake of this technology in this kind of locations. So another thing that is very important on the farms, it's the water evaporation. So, and water evaporation in this region it's quite high. So it's estimated to be around 35 cubic meters per kilogram of fish produced. And this is quite high. And farmers, they do look for ways to reduce this water evaporation, and of course the RAS systems is one of the ways, but then you need to kind of to balance the benefits and of the system, and especially the production costs. So in terms of the factors determining the profitability of these systems, of course, productivity, it's one of them. The price of the products, which I think is very important here in Southeast Asia, and of course the investment, initial investment, and operating costs. Initial investment, it's particularly a very big problem in this region, because most of the farmers, they are normally small farmers, so the industry is very fragmented. It's not a consolidated industry like in the salmon. So, and this initial investment and the access to capital, it's not easy, and this might be also a factor that influences how farmers can invest on this kind of technology. So what you see nowadays is that the farmers, they are still interested on the RAS, but they would prefer to use simple systems, even if there is a loss on productivity and stocking density. And of course, this simplicity, it will reduce the operational costs. And this is kind of what you see, and it's part of the examples that I will show you later. So there is a huge ponderation between the benefits of using the system and the cost of using the system. And this is what you really see on the field when you start visiting the farms. So in the next couple of slides, I will just show you some examples of RAS concepts applied in different farming structures. And of course, and this is why it's very different concept from what you see in these high technological farms in Norway. But at the end, if you really think on the theoretical concept, it's there, the theoretical concept. So, and this partitionate aquaculture systems. So this is quite used in many countries in Southeast Asia, especially producing shrimp. So in case you are not very familiar with the shrimp production, so like around 7 years to 10 years ago, we had a very huge outbreak disease in shrimp caused by a bacteria, via Vibrio paramyeliticus. That was baptized as early mortality syndrome. And one of the ways to fight this disease was exactly to have a closed system, so closing the water inflow from the environment, because this bacteria is kind of opportunistic bacteria, so it's always in the environment. And what they did was having like a system of polyculture where they will have tilapia especially, filtering the water, and then in the raceways, in the big raceways, they will have the shrimp. And of course, after that, they will have mostly sedimentation tanks. And all these systems were done in recirculating aquaculture with very almost like 5% or even sometimes less of water in inlet. So another good example that actually is growing quite fast, especially in countries like Myanmar and Vietnam, is these vertical systems that are using RAS concepts to produce crabs. So in this case, you see it a lot on mud crab and on soft shell crab. So and this is a totally closed system. and it's quite profitable, but the system at the end it's very profitable. So in terms of the crayfish, the crayfish production, trying to answer the question that was mentioned before, so it's growing quite fast. So especially in China, it now, if you look to FAO statistics, is becoming the second most produced crustacean after the Vanamei, the white-leg shrimp, but mostly it's in pond system, so it's not cultivated in RAS system, because it's also a quite low-cost species. So then you have also concepts of RAS being applied on shrimp farming in land, but still in open sky. So it's quite simple systems, recirculating systems with concrete tanks, or with sometimes with what we call lined tanks with a plastic, let's say, a bottom, lined bottom, and they use mostly sedimentation tanks, and for the, let's say, for the what we will call in the normal RAS system biofilter, they use mostly probiotics. So and this is mostly like closed systems to save the water, and especially to be isolated from the water in the exterior, because of its bacterial load. So the same concepts are being applied, and you see being applied in different systems to cultivate freshwater species, and you see it quite a lot also, this kind of systems, especially in China. So one of the main trends is in the shrimp industry. So as you see here on this middle picture, so this is in Indonesia, where you have like practically like islands that are filled with earthen tanks that they produce shrimp, and this basically it's being abandoned, this kind of system, because of the biosecurity. And what you see is that they are coming indoors. So, and this is two examples of the industry. One of the examples is from CPF, so CP Foods in Thailand. So it's one of the biggest companies in the world producing shrimp in a vertical way. And basically they are moving to indoor systems where they apply the RAS technology to cultivate. And the main driving factor here is really the biosecurity. And the same thing you see in Viet Hook in Vietnam, which is the biggest shrimp in Vietnam. Okay, so one of the other systems that it's very common, especially in the shrimp production, but you also see it in tilapia, because the tilapia, they also can filter the water, so they don't need necessarily to eat pellets. But this is mostly common in shrimp, that is the biofloc production. So in the biofloc production, it's as the name says, so there is the production of a biofloc that is suspended by the manipulation of nitrogen and carbon in the water. And this is also used the RAS systems. And as you can see here in the photo, it's using, well, you see like the RAS and very basic materials. So canvas tanks with aluminum frames and very simple technology applied. But the truth is that these systems are highly profitable, and you see it quite a lot in the industry. So another more expensive systems that you could a little bit compare more with what you see in Norway is what it's called in Singapore by the floating closed container systems. So basically this is RAS systems that are built in boats, and they are floating in the water. So this is two examples that you see in Singapore. So SAT for the Singapore Aquaculture Technology and DACE. So and basically, so these tanks, they don't have contact with the water in the environment, and this is basically a response to address the land the low land availability in Singapore. So there is a pressure to produce in the sea, and also to address the challenges related with the climate change. So the water, it might have high bacterial loads, and quite frequent the algae blooms producing biotoxins that can kill the fish. So this is something that we have been kind of seeing growing quite a lot here in Singapore, and it's a kind of very sophisticated system to cultivate. And here in this system, they are cultivating mostly Asian sea bass and grouper, so more expensive species. So
Rui,
basically,
if you can start to
yes,
wrapping up. Thank you.
I will just conclude. So basically, what we see here is so the RAS is being seen as a solution to address the challenge that we face. The big problem is still that the energy and the costly of these systems. So one of the things that we see is that as the challenges increase, there is a complex technology that is implied, and with the complexity, there is a lower adoption. So and the question that it stays is like the complex to whom, and the adoption is also to whom. And the example that I would like to bring to discussion is like is also the Tesla, right? So the Tesla is a very complex car, so not even the Chinese could be able to copy, but to the user, it's quite easy to use. So even a teenager without driving license can use. And this is kind of what we are thinking here in Singapore, how to produce systems that can be complex to address the challenge that we need to address, but somehow simple for the user. So, and yeah, my take home message is that yes, we see RAS adoption in Asia, probably not in the standards of the Western countries, but we see the methodology being applied. And we will see it more in the future, because the challenge that we have in the region, especially with the freshwater utilization and the high variations of temperature and salinity, we will see the adoption, but probably not going in the same direction as the Norwegians with the complexity and with the cost structure of the salmon. Yeah, and that's it. Thank you very much. Yeah.
Thank you so much, Rui. There was a very comprehensive and clear presentation. Thank you so much. We would stay here for much longer. We already have a couple of questions in the chat, so I will address them all at the end. Rui, I would just have a very short comment when you mentioned the prices, and these are fairly low value species. I would just add that we keep forgetting the environmental costs. We always leave the cost to the environment, all the social costs that we all pay for in our everyday lives. We leave it out of the product. So a product that is actually finding a more sustainable way of being produced should be somehow incorporate that in their prices. Always the cell in the Excel that is always forgotten is the environmental costs or the environment benefits of the product. But thank you so much. We already have our next speaker in line. So Inger, thank you so much for being here with us. So Inger, she's the head of fish health in the West region of Åkerblå. And Inger, you might start by teaching me how to pronounce Åkerblå. Thank you. Floor is now yours.
Yeah, thank you for the introduction and also the invitation. My name is Lise Breivik, and I'm a fish health manager, as you said, at Åkerblå. I also have 10 years experience from land-based production. And I'm here to talk about large-scale and commercial RAS farming in Norway. I just have a few words about Åkerblå first. Åkerblå is a leading knowledge-based marine health company and delivers interdisciplinary experience in fish health, environmental and technical services. We have customers both who operate both on land and sea. And every site are obligated to have a veterinary or a fish health person visiting the site either 6 or 12 times each year. It's regarding to which site it is. In the recent year, there has been a huge development in land-based aquaculture in Norway. And here is some example how it's look like. Many large land-based facilities, and then I mean really big facilities, are on the drawing board. Many are under construction and others are already in full production. Many of them are small facilities, while others are planning to take the smolt all the way to slaughter. This is, growing out farms. So they do everything on land. So the question is maybe why are we building these massive sites when we have this long coast along the whole of Norway? But the biggest challenge we have in Norway regarding to sea farming is the sea lice. It creates a lot of trouble for the fish farmer along the coast, and maybe especially on the west coast, where we are located. They must treat or handle fish to delouse it, often several times during the production cycle. And too many delousing can lead to poor fish welfare, and the operation are also very expensive. The goal with large smolt is therefore to shorten the production time in the sea. Hopefully, we'll then have less challenges with lice and also other diseases. The farmer also hope for higher production and better utilization of the MTB, as we say in Norway, but I guess the English word will be MBP, and that's maximum permitted biomass in the sea. And this graph shows the potential in producing big smolt, and the numbers are collected from last year and the great generation of spring 2022. The example shows 3 groups of fish that were put to sea roughly at the same time, week 11 and 12. So that's in the middle of approximately in the middle of March. Red, they were around 1,200 grams. The blue graph, they were 630, and the green one was about 200 grams when they were put to sea. The red and the blue line is a RAS fish. The green line is ordinary smolt from a flow-through system. The red ones was slaughtered already in week 39 at 4.9 kilos, and they just had a total time in sea for 28 weeks. And this is how we want the fish to produce: good growth, fast production, no problems during the sea period. The blue line was slaughtered in week 52, about 5 kilos. Total time in sea, 40 weeks. Also a good group, a good production, but you can see in the end there are some treatments. These small hatches in the graph. Do you see my pointer? Here's a small hiccups in the graph or in the line. They need to, when they start, they have some treatments at the end, and when they start when they treat the fish, they need to starve it, delouse it, and then it takes some time before the fish starts eating again. The green is slaughtered in the May the following year, so total time in sea was about 58 weeks, and they had a really bumpy ride at the end. Many delousing and poor growth. You can also see almost like a stair in the graph, and this would have continued if I had shown you all the production cycles. The graph also flattens out, and the fish grows slower and slower. So the longer the fish is at sea, the worse it gets. Building big on land has many positive aspects, especially if they build plants that are recycling the water. They use a much less water. They have a much less water consumption. And an example, an old-fashioned flow-through system can maybe produce 150 ton a year, but a RAS system can maybe produce 3,000 ton with the same amount of water. So this is a huge difference. The farmers can control the water quality better. They can adjust the temperature, the pH, the salinity, and so on. And during the winter, they can also have higher temperature and faster growth. Where they normally would maybe have 2-3 degrees and poor growth or almost non-growth. They have a good production throughout the year. The fish are cool-blooded, and many of the processes are also controlled by the temperature. So in RAS, when the temperature is higher, they also respond better to, for example, vaccination. The RAS water has much higher conduction, and with their ions, this multiplication also goes smoother and faster. This could also, of course, have something to do with the higher temperature. But there aren't just upsides with big facilities. I think Svein was in on some of the problems, and there are also facilities that have had big problems. And this large new facility requires a lot of the people who operate it. They must have good understanding of the biology, chemistry, technology, and also the complex interaction between these three. In Åkerblå, we help customers get started. We help them create these biosecurity plans, help them create procedures, finding responsible limits for their facility, and also give them advice regarding the water quality and fish health. A well-run RAS system can be amazing, but there are also many bumps in the road. From going from a flow-through system to a big modern RAS facility is almost like going from a bicycle to a race car. You need to have control over the water quality at all time. The waste products can accumulate fast, so good routine, daily checklist, dedicated people is the key to success. The investment cost is high, and you need trained persons in many fields, ranging from biology to the ones taking care of the fish, to industrial mechanics, maybe even chemistry or process operators. The worst thing that could happen is maybe stop in the power supply, then nothing is working and you don't have much time to fix it before all the fish is dead. Redundancy is therefore essentially for many of the technical equipment, extra power supply, control systems, sensors, and so on. Another big risk is, of course, the pathogens. If you're unlucky to get pathogens in, you cannot isolate one tank as you can in these flow-through systems, but you have it all in all the systems at once. So to sum up, you need to have good production plans. They need to be achievable and at the same time have enough slack for unforeseen events. There could be delayed boats, higher growth, many things that can happen during the production. Handling, focus on gentle handling in all operation, moving, grading, vaccination of the fish, and you have to be really take care of the mucus layer. This must be preserved. So the equipment in the different sites must be customized. Biosecurity is also a key factor. Having a good plan for different zones in the facility, good control of the water going in and out of the facility, frequent removal of sick and dead fish, keeping the system free from sludge, so on, and overall reducing the pressure of infectious agents. Power supply, I talked about that a little bit earlier. You need backup generators big enough to restart and handle the most important components. The process needs to be up and running in just a few minutes. Other technical failures, breakdowns of individual components such as pumps, oxygen cones, and so on, you always need to have a backup and preferably a backup on that as well. So the taking home message is that big sites need control. There are many components, as mentioned, and the equipment needs to work 24/7. Having good routines, checklists, and dedicated people is I think, the key to success. So I guess the questions maybe come after.
Okay, thank you so much, Inga, to lay down all the challenges that RAS systems pose to us. I hope that you have some of the answers if someone wants to start a RAS system, and how we can go around these challenges. But it was a very clear and helpful presentation. And now we have Paulo. Paulo, you also have a final message for our participants. Please.
Yes, thank you,
Go ahead.
Claudia. So as I mentioned in my previous presentation, AmpliAqua will have 2 training courses during next year with the support of Morefish. Svein and Ragnhild that are here will give some of the lectures. The first will be an online course with approximately 16 hours long, 4 sections of 4 hours, to be held in the first quarter of the next year, and the second will be a 4-day face-to-face course in the middle of the year. So both courses will cover RAS systems in detail, with the main difference between the two courses being the RAS design in the face-to-face course. So where a whole day will be dedicated to dimensioning and sizing each RAS component. So we don't have the exact dates for each course yet, but if you'd like to be updated, I suggest you subscribe the Food for Sustainability newsletter at foodforsustainability.org. We'll announce the courses as soon as we set the dates, and we'll promote them on our platforms. Thank you. That's it. Okay.
Thank you so much, Paulo. So can you just clarify? It sounds very interesting what you're proposing here. What is your target audience for this course, and whether you need the previous knowledge to attend the course?
So the online course, you don't need previous knowledge. Could be students, people who work at aquaculture facilities. The second course, it's for more specialized persons, people who works at aquaculture, or people who want to know more about it.
Okay. Okay, so we will definitely follow these initiatives. Thank you so much, and hope that you all subscribe to the Food for Sustainability newsletter. So I'm very glad that we now have time for some Q&A. So I invite all our speakers to come to the floor. You are already in the floor, so let's move on. I think we have a question, very interesting. I know that Rui, you already touched on this question, but it's the question of the energy. How much energy is our RAS systems using in countries from Southern Europe? But at the same time, I think the question is how countries that have less sun, for example, deal with the question of energy in RAS systems. So I will launch so how do you perceive energy? How do you perceive energy in warm countries? Rui, you work in Asia, it's probably easier for you to kick off this discussion.
Okay, so I think it's a very difficult question because, well, I guess that the energy consumption by the RAS system, it will depend a lot on the complexity of the RAS. And but here in Asia, we face two problems. That one of the problems is the availability of the energy, which in some places you don't even have this. So you have energy by using diesel generators, and this of course makes everything more expensive. And of course your CO2 footprint, then it's not very pleasant. So these generators are mostly used for emergency situations. So, and that's why that's one of the bottlenecks for not using these high energy intensive systems. And for the places where they are using RAS systems more complex, like the ones that are used in Norway, for example, here in Singapore, what you see already is a kind of a mix between using generators and using solar panels, and this you see quite a lot. Yeah, and I think that's more or less what I can say.
Okay, Svein, Inger, for you, the Norwegian experience, is it the same? Do you use solar panels? How do you address energy consumption in RAS systems?
Well, not so much solar panels in Norway, at least for the time being.
Why?
But Erik, a friend of mine, posted a figure about energy consumption in RAS in the chat, showing that it's somewhere between 6 and 12 kilowatt hours per kilo. But it's a huge difference between each farm. And for the salmon, it's maybe many of the farms need to cool the water actually, because the RAS production produces some heat, the pumping produces some heat, the bacterial degradation produce some heat. So cooling is also an issue actually, because it's like 12 degrees production, and not more than that. And we use heat pumps, heat exchangers to control the temperature mainly, not so much solar panels.
Yes, I was just teasing you, of course. Inger, do you have the same experience as Svein?
Yeah, I almost the same. And also in Norway, we are lucky with much rain, so we have energy from the waterfalls. So that's maybe also a good and environmental friendly energy. And also agreeing with Svein that it's maybe the cooling, not the heating, that's the problem the problem in especially these big sites. But there we
Okay,
can
so
have maybe see that we can växla exchange
Yeah.
heat exchange with seawater is often used in big sites.
okay, so my understanding is that the energy needs to be looked at the individual basis and see what is the best way to manage the process. Paulo, AmpliAqua, have you factored in energy costs for the process?
Yes, and probably that's why there aren't salmon RAS facilities in Portugal because of the water temperature. But there are other ways to solve this problem, mainly the water intake. If we can capture water more or less close from the coast, we can reach low temperatures. But of course, it's extremely expensive, as Sven and Inger told, to cool down the water. That's the main issue. And the electrical power in Portugal, it's much more expensive than in Norway.
But we can use solar panels, right,
Yes,
Paulo?
but yes, we can use
That's
solar
an option
panels.
for us, and more and more and more. Okay, just moving on to a different topic. We go back again to the reuse and the valorization of fish waste. We spoke specifically about the solid waste for biofertilizers. Is there any other uses, common uses from fish waste from these systems? Or
Yeah, there are, well, the aquaponics concept is one, and there's a big farm in the northern US doing this big style, American style aquaponics. It's called Superior Fresh, and if you Google it, you find some very nice YouTube videos about this production, and they utilize the nutrients for growing plants in large scale.
Mhm. That's interesting. Very, very good to see there are, again, industry synergies, and that's, each single market, is pulling the other one. We have a question here for Rui specifically. What do you think are the main difference in RAS between Europe and Asia? As we very clearly saw that Asia is at the forefront also of producing aquaculture.
Well, at the moment, I think it's the simplicity. So when you look to the systems here are much more simple. So of course, this it's a balance between the productivity that you have in the system and the complexity of the system. But that's mostly what you see: more simple systems, and especially compared with the standard of Norway. Of course, this picture is changing with the salmon industry coming to Asia and to Japan and so on. So they are bringing the technology here. And somehow it's influencing as well the players that here in the ecosystem, that they see the technology. So here in Singapore is one of the examples of that. That's the technology that we have is a little bit more similar to the European technology, but in general in Southeast Asia, I will say that is much simpler technology.
So my question is an obvious one for those in Europe, Svein, Paulo, and Inger. What are the added the advantage of complexity?
Well, difficult question, huh? Well, I don't know. It's plus and minuses actually, but I think we need to have better control in terms of better sensory systems to to have a safe production at high intensity. But it could be done of course, with less control, but maybe not so high intensity though, lower density. I don't know, but very much. I like the map you showed, Rui, who put the global aquaculture production in place with the big Asian production continent. But of course, we need to. Asia should start recirculate much more of the water, because it's scarcity and climate change. But then again, we need to maybe construct systems that is more autonomous. So you don't need to have this demand for high competence to run the farms. More technology, more sensor systems, more artificial intelligence, maybe. So more autonomic systems could be a solution.
Yeah, I totally agree. I think the user friendship, let's say, it's very important, and especially here in Asia, because you know that there is still a transitioning from fisheries to aquaculture. So the talent, it's scarce. So there is not much talent in the, even if it's a very big industry, there is not much talent. So if you have very complex systems, people will not be able to use them, and of course then the mistakes will happen. So it needs to be user friendly. That's what the perception that we have here.
Okay, I would definitely also add that complexity surely allow us to produce in ways that wouldn't be possible in a different way. It will probably allow us to tackle questions of sustainability. So I'm pretty sure the complexity is taking us to a level that wouldn't be achievable if we didn't have all this science. We are reaching the end of our webinar. I have here an interesting question. I'm also quite curious. So what would be the minimum size of a RAS system to be economically viable in a Mediterranean country? And, you know, we might have some people wanting to start this journey here in the audience. Can you give us a rough number, investment and production? Or, again, it's a difficult question.
Yeah, it depends on actually it's so many factors. But the main cost drivers in RAS farm is energy and feed, and that is something you can't avoid. Well, to a certain degree, maybe with solar panels and so on, but not the feed cost. So there is a limit of how small the farms can be. But of course, also the price of the fish and the operational cost, the cost of producing the fish species will matter a lot. If you see kingfish, yellowtail, it's paid 15 euros and up. So it's twice the price of salmon, and it grows almost twice as fast as salmon. Well, not so much, but it grows in 3 kilos in 300 days. So it depends on many factors. We have to calculate that.
Okay, so we need to be careful if we are thinking of replacing our aquarium by a race system. We need to.
Yeah, you should think about the operational cost.
Do our calculation.
Yeah.
Yes, thank you, Svein. Thank you for that. So when I will just ask you all as a closing remark to what would it be your key message to our audience that are here today, wanting to know a little bit more about RAS systems as either focus for experts or consumers or people that are concerned with sustainability. Just pick one message so that we all can take home.
Well, I would say join Paulo's seminars next year.
I agree.
Yeah. That's the first one.
Sounds very good.
Yeah.
Yes.
And you get to know a lot more of this.
Okay, thank you, Svein. Anyone else? No? Okay, it was really a pleasure to have you here. It's very good for me personally to see Food for Sustainability webinars coming live again. We will definitely be on the lookout for, the RAS systems and of course Paulo's sessions. It was very informative. I think we've learned a lot about what are RAS systems, the challenges, the opportunities, and eventually found here possibilities for collaboration. Dear, thank you for all our speakers and to our participants and to the questions that you raised. And if you want to know more about us and our webinars, as Paulo says, subscribe to our newsletter. So I hope to see you again soon. Have a nice rest of the day. See you soon. Thank you. Bye.
Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.